Hello everyone. Last time we described VXLAN tunnel establishment, MAC address learning, and packet forwarding processes through BGP EVPN in intra-segment layer 2 interworking scenario. This time, let's talk about how to establish VXLAN tunnels and forward packets through BGP EVPN in an inter-segment layer 3 interworking scenario. Layer 3 interworking scenarios are classified into the centralized and distributed gateway scenarios based on the gateway deployment modes. In a centralized gateway scenario, Type 3 BGP EVPN routes are advertised between the leaf and spine nodes to establish VXLAN tunnels. Layer 3 gateways are deployed on the spine nodes. All inter-subnet traffic is decapsulated and encapsulated using VXLAN and then forwarded through the spine nodes. The leaf and spine nodes can communicate with each other at layer 2 on the same subnet. The tunnel establishment and MAC address learning processes in this scenario were described last time, so I will not go into more detail today. The following describes the distributed gateway scenario. In this scenario, spine nodes function only as transparent transmission nodes, and leaf nodes function as VXLAN layer 3 gateways. Type 2 or Type 5 BGP EVPN routes are transmitted between the two leaf nodes to establish VXLAN tunnels and advertise routes. Only 32-bit masks can be transmitted through Type 2 routes, which can be used for host-to-host communication. Type 5 routes are also called IP prefix routes. Both 32-bit and non-32-bit masks can be transmitted through Type 5 routes. Transmitting network segment routes allows hosts on a VXLAN network to access external networks. The following uses Type 2 BGP EVPN routes as an example to describe how to establish a VXLAN tunnel and implement layer 3 interworking between hosts in a distributed gateway scenario. For example, when host 1 connected to leaf 1 goes online, it sends an ARP packet to leaf 1 so that leaf 1 can learn an ARP entry of host 1. In addition, leaf 1 can also obtain the corresponding layer 2 VPN and layer 3 VNI information based on the BD to which host 1 belongs. VPNs are used to distinguish the routing tables of different tenants. Because tenants connected to a leaf node may reside on different network segments, you need to bind layer 3 gateways to different VPNs to isolate routes on the leaf node for implementing inter-tenant isolation. Layer 3 VNIs are used to identify the VPNs. According to the obtained information, leaf 1 saves the host route of host 1 in the local VPN and sends a Type 2 BGP EVPN route to leaf 2. Information carried in a Type 2 BGP EVPN route includes the local VTEP address, host IP address, MAC address, layer 3 VNI, and outbound RT value of the EVPN instance. After receiving the BGP EVPN route from leaf 1, leaf 2 checks whether the outbound RT value carried in the route is the same as the inbound RT value of the local VPN. If they're the same, leaf 2 saves the route of host 1 in the VPN routing table based on the host IP address, MAC address, and layer 3 VNI information. In addition, if the VTEP IP addresses of both ends are routable, a VXLAN tunnel destined for the remote end is established. In this case, a VXLAN tunnel is automatically established between leaf 1 and leaf 2 through BGP EVPN. When the tunnel is established and host 2 sends a packet to host 1, leaf 2 finds the corresponding BD and the VPN corresponding to the BD depending on the inbound interface of the received packet. Leaf 2 then searches for the route destined for host 1 and layer 3 VNI information corresponding to the route in the VPN routing table. It encapsulates the packet using VXLAN based on the obtained information and forwards the packet to leaf 1. The encapsulated VXLAN packet carries layer 3 VNI information. After receiving the VXLAN packet, leaf 1 decapsulates the packet, finds the corresponding VPN based on the layer 3 VNI carried in the packet, finds the route destined for host 1 in the VPN routing table, and forwards the packet to host 1. The preceding information presents how to establish VXLAN tunnels on switches and enable switches to learn MAC addresses or routes and forward packets through BGP EVPN. Tunnels between switches in a data center and VXLAN tunnels between data centers can be established using BGP EVPN to implement inter-data center interworking. For example, in the E2E mode, an E2E VXLAN tunnel is established and MAC addresses or routes are transmitted through BGP EVPN between two data centers to implement inter-data center communication. In the segment VXLAN mode, a VXLAN tunnel is established through BGP EVPN in each of the two data centers, and another VXLAN tunnel is established through BGP EVPN between the data centers. The VXLAN packets received from one data center are decapsulated, encapsulated, and then sent to the other data center for inter-data center communication. That's all for today. Thanks for watching, and see you next time.